All right, let's talk about one of the most powerful and maybe one of the most overlooked forces that shapes our planet's climate. It's a massive ocean current system, and its name is the AMOC. Let's get right into it. I mean, just let that sink in for a moment. An ocean current bigger than all the rivers on Earth combined? Just stopping. It really does sound like something out of a disaster movie, right? But this is a very real question that scientists are seriously grappling with. We're talking about a planetary scale engine here, one that has been shaping our climate for thousands and thousands of years. So let's pull back the curtain on this unseen engine. What is it, really, and how in the world does it work? Let's break it down. Okay, so the official name is a bit of a mouthful, the Atlantic Meridional Overturning Circulation. We just call it the AMOC for short. And at its heart, it's basically a giant loop. The best way to picture it is as part of this huge global conveyor belt that's always moving incredible amounts of water around the planet. And the whole thing is driven by two surprisingly simple things: temperature and how salty the water is. So how does this engine actually run? It's a pretty amazing process, really. First, you've got this warm, really salty water from the tropics, and it's flowing north, right on the surface. Then when it gets way up into the North Atlantic, it starts to get cold. And what happens when salty water gets cold? It gets much, much denser. And that cold, dense water, well, it sinks. It plunges deep down into the ocean. From there, it begins this long, slow journey back south, deep underwater, eventually completing the whole circuit. It's this constant cycle.
Okay, so it's not just a loop of water moving around. You've got to think of this thing as a planetary thermostat. It has these absolutely massive effects on our climate, way beyond just the ocean itself.
And the scale of this thing is just mind-boggling. I mean, look at that number, a full 25%. This current is like a heat superhighway. It's literally grabbing warmth from the tropics and shipping it north, accounting for up to a quarter of all the heat that gets moved toward the northern hemisphere. That's huge. And here's what that actually means for people on the ground. Think about places like Great Britain or Scandinavia. The reason their climates are relatively mild is almost entirely because of this heat delivery service. Without the AMOC, that whole region would be dramatically colder. We're talking 4 to 10 degrees Celsius colder on average. It's what makes a huge chunk of the world a lot more, livable. And get this, it's not just about heat. The AMOC is also a massive player in the carbon cycle. See, when the deep water rises back up in other parts of the ocean, it brings all these nutrients to the surface. That's like fertilizer for tiny ocean plants, phytoplankton, which then bloom and suck up CO2 from the air. And then, remember that sinking water up north? When that cold water sinks, it takes a ton of that CO2 with it, basically locking it away in the deep ocean for hundreds of years. It's an absolutely critical carbon sink. Okay, so we've established this system is incredibly important. But here's the catch, and it's a big one. There's more and more evidence that this planetary thermostat, well, it might be starting to break down. Now, the idea that the AMOC can change isn't some new wild theory. It's happened before, a lot. When you look at Earth's climate history, it's filled with these really abrupt, dramatic shifts. You have events like the Younger Dryas, which was this sudden, intense cold period. And what caused it? A massive flood of fresh water from melting glaciers that basically slammed the brakes on the AMOC. So history tells us loud and clear, this system is not always stable. It can and does flip. And that brings us right to today. Because what's happening now? Well, it sounds eerily familiar. Climate change is warming the ocean surface, and it's melting ice sheets in places like Greenland at an incredible rate. All of that meltwater is just pouring fresh, unsalted water into the North Atlantic. And that makes the surface water less salty and therefore less dense, which makes it a lot harder for it to sink. It's disrupting the very engine that drives the whole system. So, as you can imagine, this has kicked off a really intense debate in the scientific community. It's kind of split into two camps. On one side, you have most of the big, comprehensive climate models. They generally show the AMOC weakening, for sure, but they don't predict a full-on collapse this century. But some scientists are pointing out that these models might be a little too conservative, maybe a bit unrealistically stable. Then, on the other side, you have scientists looking at physical evidence from the past, like ice cores and ocean sediments, and that data is telling a different story. It suggests the AMOC is already weaker now than it has been in over 1,000 years. And the warnings are getting more and more urgent. Just listen to this quote from a study in Nature Geoscience. In 20 to 30 years, it is likely to weaken further, and that will inevitably influence our weather. So we're not talking about some far-off, distant future here. This is about changes that could affect our weather, our lives within the next couple of decades. So let's go there. Let's ask the really big question. What would life actually look like if this system didn't just slow down, but hit a tipping point and just collapsed? Well, the first and most shocking effect would be a massive rapid cooling, particularly in the North Atlantic. We're talking about average temperatures across parts of Europe dropping by 4 to 10 degrees Celsius. To put that in perspective, some models predict that winter temperatures in Scandinavia could drop by up to 30 degrees. That is a completely different world. And here's where it gets really weird and counterintuitive. While Europe is plunged into a deep freeze, the US East Coast would have the opposite problem. You'd see a dramatic acceleration of sea level rise. The whole dynamic of the ocean currents would shift, causing water to literally pile up along the coast, potentially 3 to 4 times faster than the global average. And the effects wouldn't stop there. This is a global system, so a collapse would have global consequences. The tropical rain belt, this band of rainfall that is absolutely vital for agriculture that feeds billions of people, it would likely get shoved southward. This would totally redraw the map of weather patterns, causing catastrophic droughts in some places and devastating floods in others. Just to make this super concrete, let's look at one specific example. A study looked at what would happen to farming in Great Britain. Right now, about 32% of their land is good for growing crops. After an AMOG collapse, that number would plummet to just 7%. Imagine the impact on food security, on the economy. It would be absolutely devastating. So with stakes this high, you can bet the scientific community is scrambling. It is an absolute race against time to get a better handle on this and figure out what the future of the AMOC really looks like. And one of the biggest efforts on this front is something called the AMOC Assessment Initiative. Think of it like a super group of scientists. They're bringing together the top experts from all over the world to pool all the data, synthesize it, and give us the clearest possible picture of the risks we're actually facing.
And their to-do list is massive. I mean, they're looking at everything. They want to know, what's the current state of the AMOC? Where are the potential tipping points? What are the domino effects on climate, sea level, and biodiversity? What does this mean for our economies and societies? And crucially, what can we actually do about it? They're trying to come up with real strategies and recommendations for policymakers so we can be prepared for, well, whatever the answer turns out to be.
You know, the whole situation with the AMOC is just this powerful, stark reminder of how interconnected everything on our planet is and how sensitive these huge systems can be to the changes we're making. So as these scientists race for answers, for clarity, it really leaves us with one final, crucial question. It's not just for them, it's for all of us. Are we prepared for the answer, whatever it may be?